Hi, welcome to another episode of Science Made Simple. I'm Dr. Ryan, and I'm a science specialist here at the Pique Lab. In this video, I'll be analyzing a past year examination question on the topic of hydrocarbons. I've also prepared this question for you to download for free by clicking a link in the description box below. So, let's get started. We are given three pieces of information for compound Y. First, it has the empirical formula CH2. I'm sure you can remember the definition of empirical formula. Empirical formula is the simplest ratio of atoms present in a compound. In order to check if the following compound satisfies this criteria, we have to first find out the molecular formula of these compounds. This is quite an easy task, so I will give you a few seconds to try it out yourself. If you have done so correctly, you should get C3H6 for the first compound and C4H8 for the other three compounds. And if you work out their empirical formulas, you'll realize that all of them has the empirical formula CH2. So all four compounds satisfies the first criteria, which means we have to look at the second criteria. The second criteria says that compound Y has an MR of 56. To work out the relative molecular mass, you just need to add up the relative atomic masses of the atoms in each compound. You have definitely learned this before. Can you just take some time and work it out yourself? I will use the first compound as an example. In this compound, there's 3 carbon and 6 hydrogen, so its relative molecular mass will be simply 3 times 12 plus 6 times 1, giving us 42. Using the same method, you will find that the MR of compounds 2, 3, and 4 are all 56. So obviously, we can eliminate option 1. The last criteria says that compound Y forms 2 alcohols that have different structure formula when reacted with steam. Can you remember the organic reaction that this criteria is talking about? Well, this is known as hydration, which is a type of addition reaction. In this reaction, steam, which is H2O gas, adds across a double bond of an alkene, where one of the hydrogen is connected to the carbon on the left, and the OH is connected to an adjacent carbon. And after the reaction, you obtain an alcohol. If you study this reaction carefully, you can see that only alkenes, which is also a type of unsaturated hydrocarbon, can undergo this reaction. By visual inspection, you can see that option 4 do not contain CC double bond. So obviously, we will eliminate option 4. Just in case you're interested, compound 4 is also known as a saturated hydrocarbon because it only contains CC single bond as well as CH single bond. Here comes the interesting part. If you compare options 2 and 3, you can see that both of them contain CC double bond. So shouldn't both of them react to give us 2 alcohols? Well, not so simple. Let us try to reorientate compound 2 so that you can see this process better. One way that H2O gas can approach compound 2 is in this manner. Whereas another possibility is that H2O is laterally inverted and it approaches it in this manner. For the structure on the left, the red hydrogen will connect to the first carbon and OH will eventually connect to the second carbon. Whereas for the structure on the right, it is the opposite, where the OH will be connected to the carbon on the left and hydrogen will be connected to the carbon on the right. Based on the different connectivity of these two are in fact different compounds. The left compound is named butane 2-ol because OH is connected to the second carbon, whereas the right is named butane 1-ol because OH is connected to the first carbon. If you use the same approach for compound 3, you will end up with 2 structures over here, and for those of you who are quick, you'll realize that both of these structures, they are the same, and both of them are called butane 2-ol. In case you're wondering why these 2 alkenes give you such different products, this is what you have to be aware of. For compound 2, you can see that the adjacent groups on the CC double bond are different, whereas for compound 3, you can see that the adjacent groups on the CC double bond, they are the same. There is actually a special term used to describe such alkenes, but you don't really have to know them for O-levels. For compound 2, it is known as an unsymmetrical alkene, while for compound 3, it is known as a symmetrical alkene. For unsymmetrical alkenes, the general rule of thumb is that if you add another reagent across a double bond, it can potentially give you two different products. Whereas for a symmetrical alkene, no matter which way the reagent adds across the double bond, you will always end up with exactly the same product. Kind of interesting, isn't it? From what we have worked out so far, we can see that only compound 2 satisfies all three criteria. Therefore, answer is option 2. Thank you for watching, and I hope you have enjoyed this video. If you found this video useful, do give us a thumbs up. If you'd like to check out more videos by us, do click on the links on the right hand side. Last but not least, don't forget to subscribe to our channel for more interesting videos. Thank you, and I'll see you next time. Bye!